Hello Math 20-1s. Last time we learned how to complete the square to solve a quadratic equation. We're going to do that again, and that'll develop the quadratic formula. So let's follow along. Let's solve the general form of the equation for x by completing the square. So that's the general form of a quadratic equation. Ax squared plus bx plus c equals 0. So step 1, we're going to factor out the a from the variable terms. We're going to minus the c to the other side of the equation. So b divided by a is b over a. We now take half the middle term, which is b over 2a, and we square that. So that's b squared over 2a all squared. And we add that to the left side, b squared over 4a squared. Whatever we add to the left side, we must add to the right side. Don't forget that this a outside has to get multiplied to that term. So a over 4a squared would just leave us with a 4a in our denominator. So we're going to add b squared over 4a to the right side of the equation. So all we've done now is simplify the right side of the equation. Negative c plus b squared over 4a becomes b squared over 4a minus c. Our next step is to factor this perfect square trinomial and to combine these as equivalent fractions. So the square root of x squared is x. The square root of b squared over 4a squared is b over 2a. That's our binomial squared. Over here, c becomes 4ac over 4a, so I've got a common denominator of 4a. We're now going to combine the fractions on the right side of that equation. So that becomes b squared minus 4ac all over 4a. We haven't done anything to the left side. I'm now going to divide both sides by a or multiply by 1 over a. And I'll get rid of that a. So I multiply this side by 1 over a. Knowing how I multiply fractions, my denominator on the right side becomes 4a squared. So I've just moved the a from the left side to the right side of the equation. I'm now going to get rid of that radical 2, or the exponent 2, so I'm going to take the square root of both sides, remembering to keep the plus and minus. And my next step would be to minus the b over 2a. So I minus b over 2a from both sides. Notice there is no square root of b squared minus 4ac, the numerator, but there is a square root of 4a squared. So I don't have a radical in my denominator, that's 2a. What I now have is a common denominator of 2a, so I can keep that denominator and simplify the numerator, and that becomes our quadratic equation. So the solution of the quadratic equation can be found by using the quadratic formula, which is right there. That will be on your formula sheet. Don't ever forget it. You can always find it there. All right. Let's use that quadratic formula then to solve a few quadratic equations. Solve 2x squared minus 5x plus 2 equals 0. The key to this is to remember that the equation is ax squared plus bx plus c equals 0. So a, b, and c fit into our quadratic formula. They're the coefficients of x squared, x, and our constant term. All right, so a is 2, b is negative 5, c is 2, and there's our quadratic formula. So what I have to do is substitute in the values accordingly. b is negative 5, a is 2, and c is 2, and we're in great shape. We simplify this equation. Negative 5 squared is 25. 4 times 2 times 2 is 16. 25 minus 16 is 9. The square root of 9 is 3, so we've got 5 plus and minus 3 all over 4. Well, we can simplify that. 5 plus 3 is 8, divided by 4 is 2. And 5 minus 3 is 2 divided by 4, which is a half. So there are solutions. X equals 2, x equals a half. Let's try another one. Solve this equation. Again, There's my quadratic formula. I know that A is 1, B is negative 6, C is positive 7. Substitute into that formula. There's what we get. B is negative 6, A is positive 1, and C is positive 7. Simplify. Simplify, and negative 6 squared is 36 minus 28 gives us this radical 8. All right, so again, we simplify radical 8, write it as two radicals. One's a perfect square. Square root of 4 is 2. There's no square root of radical 2, so radical 8 is the same as 2 radical 2. All right. So I rewrite the solution as 6 plus or minus 2 radical 2 all over 2, or everything here is divisible by 2. 6 divided by 2, 2 divided by 2, 2 divided by 2. We get our solution. 3 plus or minus radical 2. All right. So there are two solutions there. 3 plus radical 2, 3 subtract radical 2. Awesome. Let's try another one. Let's go and solve this quadratic equation. You've got your quadratic formula. We know that A is 1, B is negative 5, C is positive 7. Substitute into the formula. B is negative 5, A is 1, C is 7. So negative 5 squared is positive 25, minus 4 times 1 times 7, which is 28. So 25 minus 28 gives me a radical that's negative. We know we can't take the square root of a negative value. So there are no real roots, thus this title. So no real roots to this quadratic equation because we can't take the square root of a negative. All right. So if I go to a different number set, the complex numbers, I can simplify equations that have no real roots. I can simplify the solutions anyway. All right, so let's just review complex numbers. An equation such as x squared plus 1 equals 0, or if I minus 1 from both sides, x squared equals negative 1. This has no solutions in the real number system. But by expanding the number system, we can give meaning to the solution of this equation. We do this by defining I with the following property. I squared equals negative 1, which can never happen. I can't square a number to get negative 1, so that I is an imaginary number. Or if I take the square root of both sides, the imaginary number is a square root of negative 1. Can't be a real number, so we call I an imaginary number, and that's part of the complex number system. All right. Since there's no real number that has its square as a negative, the number I is not a real number. It cannot be expressed as a decimal, and it cannot be expressed as a point on the number line. For these reasons, the square roots of negatives are called imaginary numbers. All right. So how can I use imaginary numbers to simplify solutions of quadratic equations? Well, let's have a look. All right. Let's solve this one. Again, A value is 1, B value is negative 6, C value is positive 13. Let's plug those into our quadratic equation. B value, A value is 1, C value is 13. Simplify. Negative 6 squared is 36. 4 times 13 is 52, so 36 minus 52 gives us a negative 16 inside the radical sign. Again, we can't take the square root of a negative number. But I could rewrite the square root of negative 16 as a square root of 16 times the square root of negative 1. And we know the square root of 16 has a perfect value of 4. The square root of negative 1 is an imaginary number I. We just defined that last slide. So I could say that the square root of negative 16 is 4i. And if I rewrite radical negative 16 as 4i, I can simplify the solution. I notice that 6 and 4 are both divisible by 2. So I can divide every term in the numerator by 2. And my solution now is x equals 3 plus or minus 2i. So I've simplified my solution using complex numbers. All right, so the roots of this equation are 3 plus 2i and 3 minus 2i. Okay, so we can try these tomorrow in class. We'll talk to you then.